Good morning, everyone. I'm Fan Zhang from University of Florida. Today, I'm presenting Investigating Virtual AI Robots in K-12 Mathematics Education, an empirical study on Ultimath platform. Our central idea is simple but powerful. Instead of interrupting students with surveys, we use natural dialogue between students and AI agents to infer engagement, cognitive load, and academic emotions in real time. I'll walk you through the motivation and our mixed method design and the early results today. Here is a roadmap for the presentation. First, introduction and the method, results, and future works. Large language models are increasingly used in education for feedback, hinting, and tutoring. However, here is a persistent weakness in our measurement toolkits. We overwhelmingly rely on self-report instruments to assess engagement and cognitive load. These instruments are valuable, however, they are retrospective, intrusive, and they miss within session dynamics. Our premise is to use the dialogue itself, what students say to the AI, when they say it, and how they respond, to read their engagement and cognitive load continuously. This approach can complement in certain contexts. It will replace the traditional service. Math is a uniquely demanding testbed for AI tutors. Prior work shows that domain-tuned large language models and strategic data augmentation can improve math reasoning and evaluation. We build on that insight. However, we shift the lens from solving math problems correctly to reading how students are coping during problem solving. Are they focused? Are they frustrated? Uh, are they ask purposeful questions? Are they seeking for help? By modeling the process rather than the final answer, we can surface early warning signal of cognitive overload and powerful and opportunities for time. Our contribution is that we give the first baseline evidence on whether talking with the agent changes students in K-12 math. Using a unified 1 to 7 scale and pre-post questionnaires, we see selective shifts: AI confidence up, AI risk awareness up, and real-life math value up, and grade forks down. While connection to the agent and concept understanding are weaker, our aims are to quantify these links, compare dialogue patterns with surveys, and pour out design ideas for future proactive support agents. So our research questions are: does the agent interaction change the students' engagement, or does the agent interaction change their cognitive load? And how do these signals get next step adaptations? Then is the methods. Our study involved 160 middle school students. They are from 7th and 8th graders. They are working on mathematics through the AltMath platform with AI dialogue agents. We combined two data sources. One is survey data and one is dialogue data. The service data provide established ground truth anchors, and the dialogue data provide fine-grained dynamics, which service typically miss. Our experimental setup is shown in the figure. Students work with a teachable agent on the Ultimate platform while we collect pre- and post-questionnaires to evaluate engagement and cognitive loads. In this presentation, we only report how we use t-tests to analyze and identify engagement and cognitive load from questionnaires to assess the agent's influence on students' learning experience. We don't cover our planned what we planned the large language model based automatic detection of engagement and cognitive load from the dialogue in this presentation. Yeah. Then is the results. For the cognitive relevant questions, we use 1 to 7 scale for all items. For cognitive load, question 2 to question 5 were above 4, so students mostly agree with those statements. Question 1 and question 6 were around 3 each, showing a more neutral or mixed views. Students didn't always feel connected to the agent. That's what question 1 said, and they were they weren't fully convinced it improved the conceptual understanding. This is what the question 6 said. So in this table we can see students don't feel always connected and they feel the AI agent won't improve their conceptual understanding. So we think the AI agent could improve the students' cognitive load during the discussion, during the conversation with the students. Then it's AI relevant questions. We can see two significant changes on the AI items. Question 1 is about the AI confidence. It went up by 0.4 and the p-value is less than 0.05. And question 6, AI is dangerous, also went up by 0.68 and the p-value is less than 0.05. So students become more confident using AI. However, they are also more aware of the risks. About the math relevant questions, most math items didn't change a lot. However, question 7, which said math is useful in daily life, went up by 0.27 and the p-value less than 0.5. And question 8, their top goal is the best grades, went down by 0.41 and the p-value is less than 0.05. This means students' engagement didn't change a lot. However, it helps students shift towards a real-life application and away from grade-only focus. We list three our future directions. First, we plan to extend across grades, subjects, and schools and test the robustness and domain shifts. Second, we want to build an in-session agent which can analyze students' AI dialogue to detect the student's engagement, cognitive strain, and emotions in real time and trigger just-in-time support. Third, about the robustness and fairness. We will audit group-wise performance to ensure detectors work equitably and stress test against noisy and adversarial inputs. That's all. Thank you. And any question here?